we're going to line up. You know, we're going to have one push pin here. Okay. We're going to have another one there. Right. They're going to be in sync. So the two chairs, wherever one goes, they both go. Okay?
Now let me ask you this. Is it safe to say that, so what we're doing is we're building a couple of these? Is that what the goal is? What are we doing?
What, today? Or
No, like in longevity here. What is
5 in a row, 4 rows.
5 in a row. So, based on this math here,
yeah,
I can duplicate this 5 deep 4 times.
Yes.
Okay.
Okay. Now there's going to be some other things. Right now we don't have a safety shield on here. If someone stuck their finger in here, they wouldn't get pinched. If they stuck their hand in here, they could get pinched.
Somebody that has an extra flab thing, the link.
Yeah.
Right.
Yeah. Some people do have that.
Mm-hmm. Got to think of their kids.
Right. So what Dave Stacker? Have you met Dave?
Yes.
Okay. What he's designing is a little side panel, and you know you'll see this when we put this back out in the garage. Mm-hmm. Okay, and they go on here, and they're going to be a little plastic and
like a plexiglass shield.
There you go.
Maybe a foam bumper.
Right, and so he's working that.
All right.
But until we get exactly that, we don't know what the dimensions are.
Well,
so
if it is pivoted here, and then you got another pivot here, then you're really.
Well, what ends up happening is those two pivots still go like this.
Aha.
Okay, but if you had your finger in there, they'd be going like this, and you'd feel the rub.
Right.
All right. The idea is that thing actually cradles you enough that you can't really get your fingers.
You don't
here.
want to do it.
Right. Now a little kid could, but then it's not going to be that close.
You might actually even suggest a tiny little nub so that you want to put your hand there.
Right. Yeah, and we've talked about that and those kinds of things. But what's happening now is we're starting to fall a little behind on that part of it.
Okay.
But we're still able to move forward on the engineering. Right. And where I'm at is this stuff is computer controlled. Mm-hmm. So I've got to get
this in sync with that.
I've got to get these hooked up. So move the electronics all under here, so I solve a couple other problems. So now we can sit it and say, yeah, that feels like a mule ride or a donkey ride or something.
Gotcha.
Oh, this feels like a boat sitting on a calm lake. You know what I mean?
Right.
So that's
is not only these what are these called?
Actuators.
Actuators.
Linear actuators.
Linear actuator.
Yeah.
Is there not only going to be linear actuator, but also maybe the rumbler also attached to this?
Yes.
Is it
a rumbler on the back seat, and Dave Stacker is the guy on that. So yeah, that's probably where you met him was when you guys were putting those on the bleachers.
Yep.
Okay. So right back here on the seat, he's actually played around with them a little bit, and the fact that the seat has the air cavity just helps it go the whole way around.
Right, so you're really getting the feel.
Oh yeah, he says he's real happy about that. And again for me, it's great that he's able to take care of it, and I'm able to focus on other things. Okay. You know what I mean? So we're definitely divide and conquer, and you're part of that.
Awesome.
Okay, dividing, not conquering. I mean conquering, not being
we're
conquered.
all conquering.
Right. So what's going on here is the seat belts. Mm-hmm. When you unclick, the electronics know that and stop the row.
Aha.
Okay.
So if there was a problem, it would automatically.
If someone decides to get out of their seat or whatever, we don't want them getting hurt, so we shut down the row.
Right. Okay. Awesome.
Okay.
Now, so these are 5 long.
Yeah, 5 in a row.
5, and there's 4 rows.
That's what we're. And let me tell you why we're going the 4 rows. Yes, very much so. Because what we want is each person, each occupant or guest, to be able to have a clear view of the screen.
Right.
So if they're sitting behind each other and somebody's sitting behind me, what do they see?
I usually calculate that into 16 in the back of their head.
Yeah.
16 inches.
Right.
Was that what you came up with?
Well, what I did was I went to Tinseltown.
Okay.
Okay. And all right, what's the width and what's the height? Mm-hmm. And they've got 18 inches.
They got 18.
16, 18. Might be 16. It's either 16 or 18.
I think it's 16.
I've got it written down.
Okay. You don't even need it itself.
But it has some interesting problems. We'd have to drill something here so that it wouldn't slip. This is what we used with a lighter weight actuator. Again, we had spread it a little bit, and you can just see that there's a whole different size, weight, quality about this. This was fine for 35 pounds. This is made for 500 pounds. That's the difference.
All right, cool. Thank you.
All right. These two circles here represent the base of the actuator clevis mounts. And do we have the actuator around? Yes. That would be this point, understanding that these are the bigger, be the bigger actuators. So they mount literally in the heavy metal in a fashion like this, and they're going to be in line. All right. So these two lines represent the actuator mounts and those points. Then what we've got is these lines going across here, here, and here are more heavy-duty metal coming across to support this guy that's suspended. And these guys are going to rest on two 2x4 cross members that then tie into the frame. So we've got everything we need structurally. So I think we got all of the the forces figured out. I'm not sure we're going to end up with that as the final design, but it was something that certainly would get the job done without question.
Yeah.
Okay. It's not a heavy-duty wire, but heavy enough, about the same gauge as theirs, and I left about 5 feet on it so that when these actuators end up moving to the from the prototype to the real model, we don't have to start buying new connectors. They're already wired up and ready to roll. We did the same thing with the potentiometers, and they just had the wires there, so I put the connectors, and we got quick disconnects. So, which are also, I know I said quick, and they are quick, but they also have a nice tight connection, which is good. Okay. When if you see the old style boards on the web, these runs here were a lot lighter weight, and they would put in 2 or 3 wires running across so that they wouldn't burn out when you started using the higher power. So I was still concerned about that, not knowing. But if you look at this board and compare it to the new model, which was purchased 3 months later, these chips have been replaced with newer models, a lot smaller. These guys are in line. We find the motion/load algorithms now that we have the new actuators and multiple USB interface card addressing and control. Now I have done some testing there. Once the second set of cards came in, and we are able to address 2 cards. So I don't view that's going to be a problem. We'll have multi-threads, a thread for each row, so to speak, and we'll just take it from there. Okay. When we're talking the line shaft, before I was a strong proponent for bolting on, and as I did more and more drilling to accept the new things, that's really getting to be a problem. Dave has always been a proponent of welding. You position everything right, you get it welded. It's now one piece of material, and I support his decision. And he's convinced me. Yeah, obviously he's got a lot more experience with that stuff than I do anyway. But absolutely, I think that's the way to go. So in the case where I've got where's the heavy duty Ys coming out, the yoke ends coming out, we might bolt those in there. We might bolt this in and then do the little weld ring down around the bottom, just to be absolutely certain. You don't have to worry about it then. The question then got to be, well, what if something went bad? He says, well, if it's welded properly, it's one piece of metal. What can go bad? Do you need to replace the Thompson actuator? Well, possibly. You're able to pull your cotter pins out, pull the pin out, and get the actuator out. The other guys coming down, again, you're going to have different options for the connections, so you'll be okay. But if you wanted to replace a pillow block bearing, that would be a problem. But again, why would you need to replace a pillow block bearing? We put plenty of them in there. If they're properly spaced, it's not a problem. We're just ready to go. Okay. So we'd have one extra of each shaft with the pillow block bearings already pre-mounted in the right spots. And if we had a problem, it's not like we're down for a week while somebody manufactures something. We're just ready to swap a part out in about an hour, hour and a half, and ready to roll. Okay.